So today I'm going to discuss a very important topic here, which is torque turning up at the moment arm. This is not momentum, this is momentum. Torque turning effect or movement arm. So this is the same name of the basic one term that we're going to use here is a torque. So what is torque? Let's just bring it here and we'll just increase the size. Okay, so we're going to discuss it. First of all, what you need to focus here is that you can focus on the entire movement. So, as you can see here, there is a pivot through which the let's just stop the video so that you can understand. Okay, let's just stop it. Okay, now okay, so this is basically a pivot point for which the door is attached, or we could say that is a point through which the door rotates. Now, consider if you just try to open the door with the help of this handle, it will easy for you to try to apply a force, like application of a force, and easily can open. But if it can open, gets open. If you talk about how if you just put it, if I just put it, shift this here. For example, now apply force. You need a little bit more force to open the door. And if you just shift this here, you need a large amount of force just to open the door. Which means that it's appropriate to say that the force in a circular path is known as the force in circular path. The force in circular path. Circular path is torque. It's easy, right? Now we have analyzed one more so that, for example, this is a distance. Let's just see. For example, this is a distance, and let's take another question. This is a distance. This is a distance L. Now, this is a distance R, and this is a distance X. Which means you need a more force R, X, or L. Then you need a more force. This is X. You need a more force to open door with this point, then this point, and this point. So it's easy for you to open the door with this point. So this is basically axis of rotation of this body. This is axis of rotation, and this is basically a momentum of potential distance. So what is torque? Torque is basically a cross product between, or it's basically a combination of the perpendicular distance this and the force. Perpendicular distance and the force. Or we could say that it is a combination between momentum. Momentum is basically the perpendicular distance and the perpendicular force. So you can use it as you will how you need to here. So at distance L, handle is situated, handle line is situated, hence small magnitude of force applied to open the door. Force distance. The two factors are needed in this question, that force. Force, and the second thing that we need in this process is distance and the angle of application. The angle of application of force. The angle of application of force is called theta. So three things are needed in the process: force, distance, and application of force. This is basically the thing that torque depends upon: force, application of force, and the distance. So let's just take an example of this door as well. Let's just bring it here. So let's take it to the other part. Let me just move this. I'll bring that. So let's just see the size. As you can see here. Oh my god. This is basically a pivot point to which it is joined. These 3 points are there. This is the handle line, to which it opens the door. This is the bell, we have to not open that. Right. So this is basically the distance L. This is the axis of rotation, or we could say that this is the axis of rotation, right? And for example, this is the something like this. Let me just tell you again. Let me just make it a bit more prominent for you. This is L. Now this is the force applied something like this. And when you shift the factor here, it has two components, X component and Y component. X component and Y component. As you can see here, X component is parallel to the axis of rotation. No, X component is basically parallel here to the pivot point. This point. It is parallel to the pivot point and perpendicular to the axis of rotation. This is the axis of rotation, it is perpendicular to the axis of rotation, but this is sine theta. It's basically, it's basically parallel to the axis of rotation. So the factor who is parallel to the axis of rotation produces rotations, while the one who is parallel to the pivot point and perpendicular to the axis of rotation will just produce no torque in the body. No, cos theta does not rotate body, or it's the factor which isn't enough to describe the rotation in the body, right? So let's take an example of fan, so it will be more clear to you. It's just a practical example. It can be the only way to explain it, and otherwise it will be to explain it. Let's just it's better to have GI. No clear GI. Here, let's just take this. Okay, let me just now open it again. This is the pivot point, pivot, axis of rotation, movement arm, and application of the force. Everything is here. This is pivot point and pivot. I'm just writing it with the P. Pivot point. This is axis of rotation AO. Axis of rotation AOR. AOR. This is the basically how to write it. AOR is axis of rotation. Now, what you observe here is basically when you apply a force, right? Your application of force something like this. It's not like perpendicular to it. Something like this. When you apply force something like this, you observe the point starts to rotate in a circular path, right? So we could say that it's perpendicular distance. We could say the torque on this slide is the distance through which the fan rotates is known as moment arm. So torque, what is torque? Torque is equals to, this is a perpendicular distance. You can see the force and moment arm are perpendicular to each other. If we just do a shifting here, because we know we always join vectors from tail to tail, you can see this is a perpendicular distance. We can never take the angles like this. We always draw a line outside and then we take angles something like this. So this is basically, you can see this is a perpendicular to each other. The torque is basically a combination of perpendicular distance or a force or a moment arm or a perpendicular force. So it's a combination of these two things. Right? The distance through which the force applied is known as moment arm. Force combined with moment arm, which is called torque. This is deeply obvious. Now I have said that they dependent upon two things, like force, we have discussed, distance, deeply obvious, we have discussed. So the next factor that I am going to conclude here is the angle of application of force. Angle of application of force. Angle of application of force that we will be discussing in later video. Okay? Angle of application of force. Application of force. Okay. Angle of application angle of